A credit card could slip through the seams between stones, weighing more than 50 tons. This is the silent challenge posed by monuments across our world, a mystery of ancient precision that defies simple explanation. Our journey will uncover how early stone builders, from the deserts of Egypt to the mountains of Peru, achieved alignments and fits so perfect they rival modern engineering, using tools that archaeology cannot name. You will gain a completely new lens through which to view human history, one where our ancestors appear not as primitives, but as masters of forgotten sciences. How did they move mountains of rock across impossible terrain, and why do their stone joints show marks that look machined? By the end, you will see every ancient site as a complex puzzle box, its secrets still locked within. What does it say about us if the past holds wonders we can no longer create? That single credit card gap is not an isolated marvel. It is part of a global pattern, a language of precision written in stone across continents and centuries. To grasp the full weight of this mystery, we must first define what these alignments truly entail. It is far more than just stones fitting together. This ancient precision operates on three interconnected levels, each more baffling than the last. First, there is cosmic alignment, the orientation of entire structures to the heavens. The Great Pyramid of Giza, for instance, is aligned to true north with an accuracy within just 3/60ths of a single degree. To put that in perspective, that is a finer margin of error than many modern architects would demand for a skyscraper. We see echoes of the same principles, a recurring grammar of precision. This suggests something profound. It points not merely to independent genius, but perhaps to a shared, foundational understanding of geometry, astronomy, and the very fabric of the physical world, an understanding so complete it has since slipped through the cracks of history. Our task now is to search for their tools, the physical means by which this forgotten knowledge was translated into stone. The sheer scale of this shared ambition is what transforms curiosity into a genuine historical enigma. Scattered across the planet, from the remote shores of Easter Island to the rolling hills of the Korean peninsula, stand silent legacies of a common impulse, a global tapestry woven in stone. These are the megaliths, the great stones, and their presence alone is a profound question. Why would cultures with no known contact, separated by thousands of miles and often thousands of years, all choose the most difficult path possible? Why lift and carve and move mountains of rock when simpler materials were readily available? This is not about a single wonder but a pattern, a recurring architectural language spoken in granite and basalt. Take the specific technique of polygonal masonry. This is not stacking rectangular blocks. It is the art of taking irregularly shaped stones, each with multiple complex angles and faces, and carving them so they interlock seamlessly without mortar, like a colossal three-dimensional jigsaw puzzle. Now find this technique in the Cyclopean walls of Sacsayhuaman in Peru, built by a pre-Inca culture. Then, travel across the Pacific and find it again in the foundational stones of ancient Japanese castles like the Osaka Castle Ishigaki, or in the sacred sites of the Jomon period. The visual resemblance is startling. It is as if two master stoneworkers on opposite sides of the world were given the same impossible puzzle to solve. This similarity led thinkers like historian John Anthony West to a provocative question. Could these parallel achievements be echoes of a much older, common source of knowledge, a foundational school of engineering and cosmology whose origin is now lost to us, surviving only in the mythologies of a global flood or a lost golden age? The logistical scale of these projects deepens the mystery. It was never just about local quarrying. It involved vision on a continental scale. Consider the iconic blue stones of Stonehenge. Geological analysis confirms these distinctive stones were transported over a staggering distance of nearly 150 miles from the Preseli Hills in Wales to the Salisbury Plain in England. This was not a random act. It was a deliberate, generations-long endeavor requiring not just stonemasons, but navigators, coordinators, and a society organized enough to sustain a dream across lifetimes. So we return to the core question with greater force. Why did cultures from the deserts to the jungles to the islands all gravitate toward this specific, back-breaking, phenomenally precise form of expression? The answer must be more profound than mere utility. This global pattern is our first major clue that we are not looking at simple technological evolution or isolated trial and error. We are witnessing the signature of a shared human priority, a deep-seated drive to create something permanent, aligned, and cosmically significant, using a methodology that appears, against all odds, to have been whispered on the wind across the entire ancient world. To understand the how, we must now look closer at the stones themselves and the marks they left behind. But if these global ambitions were so vast, the tools to achieve them must have been equally remarkable. Mainstream archaeology provides us with a familiar toolkit, a list of items we can readily understand. For shaping the hardest stones like granite and basalt, the accepted narrative points to simple implements. Dolerite hammers, stones harder than the granite they were used to pound, copper chisels which could be resharpened, wooden wedges soaked in water to expand and split rock, and abrasive sands used like a primitive sandpaper to grind surfaces smooth over immense periods of time. On paper, this seems plausible. In practice, however, this explanation hits a wall of granite. Replicative experiments have repeatedly shown a painful, almost comical gap between what these tools can do and the perfection we see in the ancient stones. At Giza, for instance, attempts to carve granite using only copper tools and sand have proven agonizingly slow. A team might work for days to make only shallow scratches on the surface. The copper, being a soft metal, blunts almost immediately against the crystalline structure of the granite, requiring constant reworking and replacement. Master stonemason Roger Hopkins, known for his work on documentaries attempting to recreate ancient techniques, demonstrated this stark reality. He found that while copper can work on softer stones like limestone, achieving the mirror-smooth finishes and precise angles found on Egyptian granite sarcophagi or obelisks was nearly impossible. The metal simply cannot maintain a sharp enough edge for the fine, controlled work required. It would be like trying to carve a detailed sculpture out of a diamond using a stick of butter. This creates a profound disconnect. We are asked to believe that civilizations which demonstrated such flawless geometric and astronomical knowledge would rely on a method so brutally inefficient for their most important projects. The time and labor calculations become staggering, often pointing to workforces of tens of thousands laboring for decades. Yet, even these immense numbers struggle to account for the precision, not just the mass. It suggests one of two uncomfortable possibilities. Either these societies commanded a scale of organized, patient labor that dwarfs our modern comprehension, a silent, unimaginable effort lost to history. Or, more intriguingly, they possessed and applied a different, more sophisticated technology that has not survived in the archaeological record, or which we simply fail to recognize as a tool. This is not to dismiss the incredible ingenuity of using sand and water to cut stone, a proven method, but for the finest work, the evidence on the stone itself whispers that something else was at play. The next clue lies not in the tools we think they used, but in the mysterious marks those tools, or others, left behind. These mysterious marks on the stone are not just scratches from blunt tools. In some places, they hint at something far more radical, a third enigma that stands as the most controversial idea in this entire field. What if the ancient builders did not just carve stone, but in some way temporarily softened it? The theory suggests they possessed a lost method, perhaps chemical or acoustic, to alter the very state of granite or basalt, making it pliable like clay for shaping before it hardened again into its final, impossibly precise form. This idea directly challenges our entire timeline of material science, suggesting a forgotten branch of practical knowledge. To approach it, we must look at two very different pieces of evidence, separated by centuries but connected by a single, baffling question. First, consider a modern mystery, the Coral Castle in Florida. In the early 20th century, a single man named Edward Leedskalnin, who stood just 5 feet tall and weighed barely 100 pounds, single-handedly quarried, carved, and positioned over 1,000 tons of coral rock. He created massive gates that rotate with a touch, perfect stone spheres and towering obelisks. When asked how he did it, he would only say he understood the laws of weight and leverage used by the pyramid builders. He claimed to have rediscovered how the Egyptians worked with the weights of the stones. While he never revealed his method, the sheer physical impossibility of his solo feat forces us to wonder if he stumbled upon some principle of counterbalance or even stone manipulation that mainstream engineering has overlooked. Then look back to ancient Egypt itself. Examine certain stone blocks, particularly in places like the Temple of Hathor at Dendera or some of the foundation stones at Giza. Their surfaces do not look traditionally carved. Instead, they appear vitrified, as if briefly subjected to intense heat that gave them a melted, almost glazed appearance. Some joints between stones show patterns and textures that look less like chisel marks and more like the stone was poured or molded into place, with material seeming to have flowed before setting. This visual evidence is what led materials scientist Joseph Davidovits to propose his geopolymer theory. He suggests that for some of the pyramid blocks, the builders did not cut natural limestone, but created an artificial stone. They could have crushed softer limestone, mixed it with a natural alkali binder like natron, and poured this slurry into wooden molds, creating a kind of ancient concrete. This would explain the lack of tool marks, the perfect fits, and even the presence of air bubbles and organic material found in some core samples. Mainstream Egyptology largely dismisses the idea of advanced stone softening or geopolymers for the largest monuments, citing the overwhelming evidence of quarrying and the sheer volume of stone involved. Yet, the existence of these anomalous features cannot be easily waved away. They represent a stubborn data point that does not fit the standard narrative. Whether through a chemical process we have yet to replicate, or through the application of sound or vibration, a concept found in legends worldwide, this enigma opens a door. It suggests that our ancestors' mastery may have extended beyond geometry and astronomy into a deep, intuitive understanding of the very substance of the world around them, an alchemy of stone now lost to time. The legends themselves may hold the most tantalizing clues of all, pointing toward a technology that leaves no physical trace. Across the world, woven into the oral histories of cultures separated by continents, we find a recurring theme, a fourth enigma that sounds more like magic than engineering. It is the idea that sound itself, the vibration of the air, could be harnessed to move mountains of stone. These are not just campfire stories, but persistent traditions passed down through generations, often tied to the very sites that baffle us today. In the high Himalayas, Tibetan Buddhist lore speaks of the construction of the mythical city of Shambhala. The legends describe not ropes and ramps, but great trumpets or long horns, whose sacred tones resonated with the stones, allowing them to be lifted and placed with an almost gentle precision. Early 20th century explorers like Andrew Thomas documented similar accounts from remote monasteries, tales of monks using chants and drums to make heavy objects lose their weight. Far across the globe, among the Hopi people of the American Southwest, their ancestral stories describe a different but related power. Their forebears, the Hisatsinum, are said to have used focused thought and sacred vibration, a unity of mind and sound, to shape their cliffside dwellings and move the materials that built them. On the surface, these sound like pure myth, the kind of symbolic language we easily dismiss. But what if, instead of being literal descriptions of levitating rocks, they are a cultural memory of a sophisticated principle? What if they encode a real, practical understanding of wave physics that has been lost to us, remembered only in the language of ceremony and wonder? Modern science gives us a startling reason to pause before dismissing these accounts. The field of acoustic levitation is very real. In laboratories today, scientists use precisely tuned sound waves to suspend and manipulate small droplets of liquid, particles, and even tiny solid objects in midair. The principle relies on creating a standing wave, a stable pattern of pressure nodes where the force of the sound counteracts gravity. While we cannot yet levitate a stone block, the fundamental physics demonstrates that vibrational energy can exert a powerful, controllable force on matter. Furthermore, research into the behavior of granular materials like sand shows that specific frequencies can dramatically alter their properties, causing them to flow like a liquid or lock together like a solid. Now consider the hardest stones like granite. On a microscopic level, granite is a crystalline matrix, a rigid structure held together by atomic bonds. If a specific resonant frequency could be found that matched the natural vibrational frequency of that stone, could it, in theory, temporarily reduce the internal friction, making it easier to maneuver or even shape? It is a radical thought, one that merges the deepest threads of human lore with the cutting edge of material science. These legends do not ask us to believe in magic wands. They ask us to consider a possibility that ancient master builders understood their materials so intimately, they knew how to speak to them, using sound not just for ritual, but as the most practical tool in their workshop. The stones themselves may have been listening all along. But their alignment to the stars required a different kind of listening altogether. This brings us to the fifth enigma, the precision of astronomical alignments achieved without a single modern instrument. This is not about vaguely pointing a building toward the sunrise. This is about engineering with the cosmos as a blueprint, embedding celestial events into the very bones of a structure with a clockmaker's exactitude. Take Newgrange in Ireland, a massive stone tomb older than the pyramids. For just a few minutes at dawn on the winter solstice, a slender beam of sunlight travels down a long, narrow passageway called a roof box and floods the central chamber with golden light. To achieve this, the builders had to calculate the exact angle of the sun on the shortest day of the year, account for the horizon's topography, and then construct a 60-foot-long stone corridor that would act as a perfect light pipe, all over 5,000 years ago. The margin for error was virtually zero, a single degree of misalignment, and the chamber would remain in eternal darkness on that sacred day. How did they plot this celestial event so perfectly, year after year in their planning, and then translate it into immovable stone? On the other side of the world, at Machu Picchu, the Intihuatana stone stands as a masterpiece of integrated design. Carved from the living bedrock of the mountain summit, it is not a sundial in the simple sense. Its angles and planes are precisely shaped to track the sun's progression throughout the year, marking the equinoxes and solstices. It was, in essence, an astronomical calendar permanently fused to the earth, a stone computer for reading the sky. As archaeoastronomer Dr. Giulio Magli points out, achieving such alignments requires two separate, profound skills. First, patient observation over generations, meticulously noting the sun's and stars' movements against fixed landmarks on the horizon. But second, and more difficult, was the act of fixing those fleeting observations permanently into architecture. they needed a method to transfer celestial coordinates from the dynamic sky to the static ground with minimal error. This implies the use of advanced yet ephemeral surveying techniques. They might have used long, straight sighting poles, perhaps made of wood, placed miles apart to create precise sightlines. They could have employed water levels, simple tools that use the unwavering property of water to find a true horizontal plane over great distances, allowing them to create perfectly level foundations from which to measure angles. These tools, being made of perishable materials, have left no trace for archaeologists to find. We only see the magnificent, immutable result. This enigma highlights something far greater than technical skill. It reveals a profound, living connection to the cosmos, where the cycles of the heavens were not just observed but were intimately woven into the fabric of daily life, governance, and spirituality. The mathematical and geometric sophistication required seems to appear fully formed in the archaeological record, without a clear period of clumsy experimentation. It is as if this knowledge arrived complete, a system ready to be applied. This seamless integration of sky and stone stands as one of the most elegant and enduring signatures of the ancient builders, a silent testament to a vision that saw earth and heaven as a single, interconnected construct. This seamless vision of sky and stone reaches its most bewildering expression not in a pyramid or a temple, but in a scattered field of ruins high in the Bolivian Altiplano. Puma Punku is not merely an ancient site, it is an archaeological anomaly that seems to fracture our timeline. Here, the andesite and granite blocks lie broken and dispersed, as if by a cataclysmic force, but each individual piece tells a story of impossible precision. These are not simple building blocks, they are components, intricate and geometric, featuring razor-sharp right angles, surfaces polished to a mirror finish, and complex channels and recesses cut with a machinist's exactitude. Among the most famous are the so-called H-blocks, massive stones carved with identical, symmetrical indentations that look less like hand-carved art and more like pieces from a giant stone puzzle designed with a drafting compass and a ruler. The uniformity is startling, each recess matching its counterpart with such consistency that it strongly suggests the use of a template, a repeatable guide for manufacturing. This implies a move from unique craftsmanship toward something resembling standardized production, a concept we associate with much later periods in history. The surfaces themselves hold the most tantalizing clues. Materials engineer Christopher Dunn has studied these stones extensively, and his observations challenge the conventional narrative. The tool marks visible on some of the hardest granite and andesite blocks do not resemble the rough, pitted surfaces left by pounding with stone hammers. Instead, he notes cuts that are straight, clean, and parallel, with a consistency that suggests the use of a reciprocating saw blade. In some of the precisely drilled holes, which are perfectly cylindrical and smooth, he sees spiraling striations, a telltale sign of a drill bit that advanced while turning under a constant, controlled pressure. To achieve such work on stone of this hardness, the cutting tool would need to be harder still. This leads to a profound question. Could the builders have used abrasives far more advanced than simple sand, perhaps diamond-tipped points or saw blades embedded with another ultra-hard crystalline material? We know that ancient cultures were familiar with diamonds and other precious stones for ornamentation, but the idea of using them in industrial tooling is a leap our historical models are not prepared to make. The most compelling details are often the smallest. Some blocks feature narrow, shallow grooves, only about 6 millimeters wide, that run perfectly straight and maintain a consistent depth along their entire length. Carving such a feature with a handheld stone or copper tool without wandering or wobbling is an almost superhuman feat of control. It is the kind of work we achieve today with a guide rail and a power tool. Puma Punku, therefore, stands as a monumental challenge, a site where the physical evidence on the ground creates a stark and uncomfortable gap with the accepted story of the past. It forces us to confront a simple, binary choice. Either the Tiwanaku culture, to whom the site is attributed, possessed a level of technological sophistication in stoneworking that we have completely failed to recognize, a knowledge that was later lost, or we must reconsider the age and origin of these ruins entirely. In either case, the stones of Puma Punku are not just rubble. They are a silent, stubborn argument against complacency in our understanding of history. The stones of Puma Punku are not the only ones whispering of lost tools. To move beyond legend and speculation, we must become detectives, examining the most direct evidence we have, the physical fingerprints left on the stone itself. Every cut, every groove, every drill hole is a silent witness to the moment of its creation, holding clues about the tool that made it, its motion, and even the mindset of the craftsperson who wielded it. This is forensic archaeology, a direct line of inquiry that bypasses ancient texts and looks at the raw data of the construction process. In Egypt, some of the most telling evidence comes from the granite sarcophagi found deep within the pyramids. On their interiors, researchers have identified long, straight saw marks. These are not the erratic, wavy grooves left by a handheld copper blade being pulled back and forth by human muscle. Instead, they are remarkably consistent, parallel lines that maintain an even depth across the entire cut. This pattern strongly suggests the use of a saw with a long, straight blade, perhaps mounted in a frame to ensure a steady, reciprocating motion. But copper alone could not have achieved this on granite. The leading theory is that the ancient masons used an abrasive slurry, a paste made from a material harder than the quartz in the granite. They might have employed crushed corundum, which we know as sapphire or ruby or even diamond dust, mixed with water or oil. The saw blade itself, possibly made of bronze or even a softer copper, would then act merely as a carrier, pressing this ultra-hard grit into the stone, letting the abrasive do the actual cutting through a slow, grinding process. This explains the straight lines, but it also implies a sophisticated understanding of material science and a patient, methodical workflow. Even more compelling are the drill cores. At sites like Abu Sur and Giza, archaeologists have found cylindrical cores of granite and diorite, the leftover centers from when a hole was drilled. These cores are miniature masterpieces of precision. They show perfectly concentric, spiral grooves running down their length. This spiraling pattern is the unmistakable signature of a tubular drill, a hollow cylinder that rotated while being fed into the stone with constant pressure. The grooves indicate the drill bit was impregnated with an abrasive, just like the saws, and turned at a steady rate. What stuns modern engineers, however, is the feed rate, the speed at which the drill penetrated this incredibly hard stone. Experiments by machinists like Christopher Dunn have shown that replicating these ancient drill cores with modern diamond-tipped drills requires significant downward pressure and careful control. The fact that the ancient cores show a consistent, rapid penetration suggests their drilling apparatus was not only stable and powerful, but their abrasive compound was exceptionally effective. These tool marks taken together paint a picture that goes far beyond men with stone hammers. They point to a workshop environment where tools were mounted for stability, where abrasives were selected and processed with specific knowledge, and where motions were controlled and repeatable. This is not primitive technology, it is specialized precision technology. It speaks of a culture that did not just build monuments, but mastered the very substance of stone through a blend of empirical knowledge and engineered tools, a combination that has left its indelible signature for us to decode thousands of years later. This mastery of stone required a master plan, an invisible blueprint written not on papyrus but in geometry. Precision alignment begins with precise measurement, and the evidence carved into these structures points to a profound truth. These builders were not just laborers, they were mathematicians and geometers of the highest order. They thought in shapes, ratios, and universal constants long before these concepts had formal names. Look at the Great Pyramid. Its base perimeter divided by twice its height yields a number startlingly close to pi, the ratio of a circle's circumference to its diameter. The Parthenon in Greece is famously proportioned using the golden ratio, a special number approximately 1.618, found in nature from seashells to spiral galaxies, and revered for its inherent aesthetic harmony. These are not coincidences, they are deliberate applications of a deep, shared mathematical language, a recurring grammar in the global architecture of the ancient world. But how did they translate these beautiful abstractions into a construction site? They used elegantly simple yet devastatingly effective tools. In Egypt, the harpodonapti, the rope stretchers, were legendary. By knotting a cord into a loop with 12 evenly spaced knots, they could create a perfect 3-4-5 right triangle every single time, the principle we call the Pythagorean theorem. Stretching this knotted rope taught them to lay out perfectly square foundations, even on the shifting sands of the Giza Plateau. They used plumb bobs, a weight on a string, to find true vertical and simpler frame levels filled with water to establish a perfect horizontal plane over vast distances. The discovery of standardized cubit rods shows they had an agreed-upon unit of measurement, but applying that unit consistently across a multi-generational project with different teams and changing overseers required a rigid system of geometry that everyone understood. This system was their true technology, more valuable than any single tool. It was a transferable knowledge, a set of rules that allowed a master builder to communicate a complex design to an apprentice using nothing more than a straight edge, a compass, and a length of cord. The geometry was the instruction manual. It allowed them to scale up, to take a small model or a diagram and enlarge it perfectly onto a landscape. Imagine needing to ensure that two walls, being built a quarter-mile apart by different crews, would meet at an exact corner months later. You could not rely on eyeballing it. You relied on sighting rods placed along predetermined geometric lines, creating an invisible grid across the entire site that every worker could reference. This abstract thinking is perhaps their greatest legacy. They saw the world not as a chaotic place, but as an ordered mathematical expression. Their temples and pyramids were not just buildings, they were three-dimensional models of this cosmic order, a way of bringing the perfect, eternal laws of geometry down to earth and making them permanent in stone. The precision we marvel at is simply the physical echo of that profound, invisible understanding. The geometry was their blueprint, but the granite was still a mountain. This brings us to perhaps the most visceral enigma of all, the sheer, staggering physics of moving these stones. We have marveled at how they were shaped and aligned, but first they had to be moved, and the distances involved defy belief. The logistics of transporting megaliths across impossible terrain is a separate, monumental puzzle. Consider the scale. In Aswan, Egypt, lies the unfinished obelisk, still partly attached to the bedrock. Had it been completed, it would have weighed an almost inconceivable 1,200 tons. At Stonehenge, the massive lintel stones that cap the famous trilithons each weigh around 80 tons and were somehow lifted over 20 feet into the air. The question is not just how they moved them, but how they did so without catastrophic failure across miles of sand, river, and uneven ground. The traditional explanation is a symphony of brute force and ingenuity. Wooden sledges glide on log rollers, pulled by teams of hundreds along pathways lubricated with water or clay. For elevation, immense earthen ramps were built, sloping gently upward over decades of construction. In experiments, these methods can work, but they reveal a terrifying fragility. A single roller snapping or a sledge tipping could mean months of work lost and lives endangered. They demand not just strength, but perfect coordination, communication, and conditions that are almost never perfect. This has led researchers to explore more speculative, yet intriguing alternatives. Could they have used sophisticated counterweight systems, like giant seesaws or balances, to pivot stones into position with less raw manpower? Some have even theorized about a manipulation of local magnetic fields or gravitational forces, ideas that drift into the realm of fringe science but speak to the depth of our bafflement. The most credible insight, however, may not be about a secret physics, but a forgotten sociology. The true unidentified tool here might have been an unparalleled social and organizational technology. Think of what was required. To move an 800-ton stone from a quarry to a temple site was a multi-year campaign. It required feeding and housing thousands of workers, maintaining a vast inventory of ropes, sledges, and rollers, managing water supplies for lubrication, and coordinating the efforts of specialist teams, from the pullers to the lever crews to the ramp builders. This was project management on a scale comparable to a modern aerospace firm or a major civil engineering project. There would have been architects who functioned as CEOs, foremen who acted as middle managers, and a logistical support network that functioned like a supply chain. They had to plan for seasons, for illness, for material fatigue, all while keeping the collective vision alive across generations. This logistical prowess is the often overlooked heart of the mystery. It indicates a society that had mastered human systems as deftly as it mastered stone. Their greatest achievement may not have been a single invention, but the ability to orchestrate thousands of minds and bodies toward a single, seemingly impossible goal, turning a mountain's worth of rock into a symphony of aligned stone, one agonizing, coordinated pull at a time. That orchestration of human effort found its perfect partner in the most abundant resource of the ancient world. While we picture teams straining against ropes, another force, silent and omnipresent, may have been doing the heaviest lifting. Water, this simple, universal substance, presents a compelling and often overlooked hypothesis that ancient builders wielded hydraulic power as a primary, precision tool for both shaping and moving their monumental stones. The concept transforms water from a passive element into an active participant in the construction process, leveraging its unique properties in surprisingly sophisticated ways. Consider the potential for cutting stone. In the granite quarries of Aswan, Egypt, some of the block separation channels are remarkably smooth and straight, with clean, vertical sides. While conventional theory attributes this to the slow process of pounding with dolerite hammers and inserting wooden wedges, a more radical idea has been proposed by some researchers. They suggest the use of high-pressure water jets, by forcing water, perhaps mixed with an abrasive sand, through a narrow, reinforced nozzle. A sustained, focused stream could cut through granite over time. While we lack direct evidence of such pumps or hoses, the principle of water erosion is undeniable, and the controlled application of that force is a logical extension of observing nature's power. The ancient Egyptians were absolute masters of hydraulics through their management of the Nile's annual inundation, using canals, sluices, and basins to irrigate their civilization. Applying that same systemic understanding to a quarry site is not a fantastical leap, but a practical one. Water's role likely extended far beyond cutting. Its most powerful application may have been in transportation. Moving a 1,000-ton obelisk from a quarry to a riverside is an almost insurmountable challenge on land. But what if the builders waited for the Nile's flood season? During the inundation, water levels could rise dramatically, bringing the river's edge directly to the quarry. By digging temporary canals or using natural depressions, they could float the massive stone, partially buoyant, onto a waiting barge or a raft of papyrus bundles. Once secured, the current itself, aided by teams of rowers, could carry the colossal load hundreds of miles with a fraction of the land-based effort. This turns a seasonal obstacle into a brilliant logistical advantage. using the planet's natural cycles as an engine for their ambition. Furthermore, water provided the ancient world's most reliable level. Before laser levels, the simplest way to create a perfectly flat plane over a vast foundation, like that of the Great Pyramid, was to dig a shallow network of interconnected trenches around the perimeter, fill them with water, and mark the consistent waterline on the trench walls. Any point along that line is at the exact same elevation. This simple yet flawless technique, using water's unwavering search for equilibrium, allowed them to establish a true horizontal reference across acres of uneven desert. Even some of the more enigmatic erosion patterns at ancient sites, like the deep, vertical weathering channels on the walls of the Sphinx enclosure, have led some geologists to speculate about prolonged exposure to flowing water, perhaps from runoff directed during construction or from tools that utilized large volumes of liquid. The water hypothesis does not require lost technology, only a profound and creative application of a readily available force. It suggests that the true genius of these builders lay in their seamless integration with their environment, seeing in a river's flood or a still pond not just a resource for life, but a ready-made machine for building the impossible. Yet another tool leaves no trace of itself, only the stones it helped to free. While water may have been a silent partner in shaping and moving, fire was likely the initial liberator, the dramatic first act in the life of a megalith. Historical records and scattered clues point to a sophisticated, almost surgical use of thermal shock, a method where fire and water worked in concert to crack mountains apart with startling control. Roman engineers like Vitruvius wrote explicitly of this technique, describing how to quarry stone by building large fires directly against a rock face. Once the stone was glowing hot, they would rapidly douse it with water, often vinegar or cold water carried in great quantities. The sudden, violent contraction caused by the cooling created immense internal stress, forcing the rock to fracture along a relatively clean, predictable plane. This was not a haphazard explosion, but a precise application of physics. The builders had to understand their material intimately, knowing exactly how much heat to apply and where to pour the water to guide the fracture, not just cause a chaotic shatter. It required an empirical knowledge of temperature gradients, a feel for the stone's character that could only come from generations of trial, error, and careful observation. This method solves a practical problem with elegant efficiency. Separating a multi-ton block from the living bedrock using only stone hammers and wedges is an agonizingly slow process, consuming time and tools. Thermal shock could accomplish the initial separation in a single, dramatic event, creating a workable block that could then be refined with other techniques. The evidence for this, however, is ephemeral. At ancient quarry sites, one might look for telltale signs, patches of rock that appear more weathered or discolored, or subtle traces of soot and ash that have seeped into microscopic pores over millennia. But rain, wind, and the passage of centuries act as a great eraser, washing away the soot and smoothing the scars of the fire. The absence of clear proof does not mean the method was not used. It simply means we are looking for a ghost, the faintest whisper of heat and steam on stone. This forgotten technique reframes our understanding of their toolkit. It shows builders who were not just strong but clever thermodynamicians who saw in the basic elements of fire and water a powerful, controllable force. They manipulated the very expansion and contraction of matter to do their bidding, turning a cliff face into a stockpile of building blocks with a mastery that feels both ancient and remarkably advanced. This clever manipulation of physics was just the beginning, for once the stone was free, an even greater challenge of coordination awaited, one that demanded a social invention far more complex than any ramp or lever. The fire left no trace, and neither would the tools that truly built the world. Our entire understanding of ancient technology rests on a fundamental bias of history. The archaeological record is a collection of what endures, a gallery of stone-fired clay and occasional metal. But what if the most ingenious, the most critical components of their engineering were never meant to last? We must confront the very real possibility that the master builder's true toolkit was organic, biodegradable, and has simply returned to the earth, leaving behind only the impossible stones they were used to shape. By focusing solely on the durable artifacts we dig up, we may be staring at the skeleton of a technology while missing its beating heart, its muscles, and its nerves. Think of what vanishes: ropes of incredible sophistication woven from specific plant fibers like hemp or flax, treated with natural resins for strength and weather resistance, capable of bearing hundreds of tons of tension. These were not crude cords, they were engineered lifelines, the sinews that pulled mountains. Consider the vast wooden frameworks, the towering cranes and lifting gantries, the complex formwork for ramps and molds. A civilization that could fell and shape giant cedars for shipbuilding certainly had the carpentry skill to create monumental wooden machines that rotted away centuries ago, leaving not a single splinter as evidence. Even the abrasives they used might have been perishable. Beyond simple sand, they could have harnessed plant extracts or compounds derived from animals, mixtures that acted as powerful chemical agents or polishing pastes. A specific berry's acidic juice, a fermented botanical slurry, or a compound made from crushed seashells could have provided the final, mirror-like finish on a granite wall, a recipe lost when the last artisan who knew the formula passed away. We see hints of this organic genius in surviving traditions. In many Asian cultures, bamboo was not just a plant, it was a construction material of unparalleled versatility. Certain species of bamboo possess a tensile strength that rivals steel, yet it is lightweight, flexible, and grows abundantly. It could be used for scaffolding, for creating flexible measuring tapes, for crafting powerful spring mechanisms or reinforcement within structures. If a culture could engineer with bamboo to such a degree, what other botanical secrets might they have possessed, secrets that left no fossil behind? This perspective changes everything. It means the quarries and construction sites we study were once bustling with a different kind of industry. They were surrounded by workshops weaving super-strong cables, carpenters assembling colossal wooden machines, and chemists brewing pots of specialized compounds. The silence in the archaeological record is not an absence of technology. It is the echo of a technology that was in harmony with its environment, designed to be replenished, not to endure forever. We are left with a grand stone question, but we have lost all the delicate, living answers. This realization forces a humbling shift. We must stop imagining ancient builders struggling with primitive stone tools and start seeing them as resourceful masters of their entire ecosystem, wielding a sophisticated, invisible arsenal grown from the very world around them. This profound integration with the natural world points toward a deeper truth about knowledge itself. In many ancient societies, the most advanced understanding was not written in books or displayed in public forums. It was a closely guarded treasure protected by priestly castes or exclusive guilds of master builders. This knowledge was transmitted not through texts, but through a sacred chain of oral tradition and initiation rites, where the methodology of construction was inseparable from cosmology and ritual. The act of building a temple or aligning a monument was itself a form of worship, a physical prayer. The precise angles, the chosen alignments, the very selection of stone from a specific quarry, each step was laden with symbolic meaning, a technical process infused with spiritual significance. Because of this, the how was often considered as sacred as the why, a secret too powerful to be entrusted to common record. This cultural practice of secrecy offers a compelling explanation for the frustrating silence in the archaeological record. We find no detailed technical manuals from the builders of the Great Pyramid or the architects of Puma Punku, not necessarily because they were lost to time, but because they may never have existed in a widely accessible form. The knowledge was intentionally kept from papyrus and clay tablet, residing instead in the memory and hands of the initiated, passed personally from master to apprentice in the hushed atmosphere of a lodge or the sacred space of a quarry at dawn. We see a direct echo of this tradition centuries later in the medieval stonemasons' guilds. These brotherhoods protected their trade secrets with a fierce loyalty, using coded symbols, secret handshakes, and ritual ceremonies to distinguish the knowledgeable insider from the outsider. The intricate geometry that allowed a Gothic cathedral to soar was not public property. It was the proprietary technique of the guild, passed down through a lineage of craftsmen. This framework forces us to reconsider the entire mystery. The unidentified tools we have been searching for might not be physical objects waiting to be dug up. They could represent an entire lost body of proprietary techniques, a living library of mathematical formulas, ritual practices, and empirical shortcuts that were never meant to be written down. This was a holistic knowledge system where science, art, and spirituality were a single discipline. The master builder knew not only how to calculate the slope of a ramp, but also which chants were to be sung while doing so, which stars should be overhead when the foundation stone was laid, and which herbal compound would best polish a specific type of granite. When the last initiate of such a tradition passed away, or when the society that sustained it collapsed, that living library vanished. It died with its final keeper. All that remained were the physical monuments themselves, standing as a cryptic, stone-bound legacy of a wisdom we can now only glimpse, not read. The monuments are not just puzzles, they are the last remaining pages of a book whose language we have forgotten. These silent stone pages may not be our only source, for other ancient texts speak, though in a language we struggle to translate. Could the practical knowledge of the master builders be hidden in plain sight within surviving scriptures and carvings? For generations, we have approached texts like the Egyptian pyramid texts or the vast Vedic scriptures of India through a single lens, interpreting them as purely religious or mythological. They are filled with prayers, spells, and stories of gods, but a growing number of researchers propose a radical second layer, that these sacred writings also function as encoded technical manuals. The symbols and metaphors might be a deliberate veil, a way to preserve profound engineering and astronomical knowledge within a durable spiritual narrative, safe from the decay of papyrus and the corruption of time. This idea asks us to look at familiar images with entirely new eyes. Take the Egyptian Djed pillar, a common hieroglyph often translated as meaning stability and endurance. It resembles a column with crossbars. Could this stylized shape also represent a specific tool, perhaps a sophisticated surveying instrument or a blueprint for a structural support system used in pyramid construction? Similarly, the Ankh, the symbol of life, has been speculatively linked by some to concepts of energy or even a schematic for a type of hydraulic device. The key word is speculative, for this is a frontier of interpretation filled with both intrigue and risk. The challenge is immense. We must avoid the trap of seeing modern technology in every ancient squiggle, a practice called pareidolia. Yet, we must also remain open to the possibility that our ancestors communicated complex ideas through a symbolic language that has lost its practical dictionary. Look at temple reliefs like those at Dendera or Abydos. They often show deities or pharaohs holding unusual, elongated objects. Egyptology traditionally interprets these as ritual standards or symbolic scepters. But what if, to an initiated craftsman, the specific proportions and angles of those objects conveyed instructions for a type of level, a sighting tool, or a template for cutting a specific joint? The same multidisciplinary puzzle appears in other cultures. The intricate geometric patterns and seemingly abstract symbols carved into the stones of Göbekli Tepe or inscribed in Sumerian tablets might not be mere decoration. They could represent architectural plans, star charts, or mathematical formulas expressed in a visual shorthand known only to the guild. Decoding this potential library requires a delicate fusion of skills. It needs linguists who understand the nuance of ancient languages, not just their grammar but their context. It requires engineers who can look at a symbol and ask, if this were a diagram, what machine or process would it describe? And it demands historians who can place these ideas back into the living world that created them, separating genuine technical insight from later mythological elaboration. This is not about claiming ancient people had light bulbs or helicopters, as some fanciful theories suggest. It is about considering that their sacred symbols were a multidimensional language, capable of holding both spiritual truth and practical instruction in the same elegant form. Perhaps the greatest wisdom was never meant to be read in a single way, but to reveal deeper layers of meaning only to those trained to see them. That symbolic language of the ancients was not just written in stone or scroll, but perhaps felt in the very ground beneath their feet. Another layer of their site selection and design may have been guided by an invisible geography, a science of the living earth we have largely forgotten. Some researchers exploring beyond conventional archaeology point to the ancient practice of geomancy, the art of reading and responding to subtle energies within the landscape. This idea suggests that master builders did not choose locations solely for practical reasons like water access or defensibility, but also for perceived telluric currents, geomagnetic anomalies, or what many traditions simply called power spots. Using methods that might seem mystical to us today, such as dowsing rods made from forked branches or a cultivated sensitivity to the environment, these ancient surveyors could have been mapping an unseen energetic grid. They sought places where the Earth's vitality was strongest, believing construction there would imbue their monuments with greater symbolic potency, stability, or even a direct connection to cosmic forces. This might explain why so many sacred sites, from the rolling hills of Britain to the mountains of Peru, feel instinctively powerful to visitors even now, places where the air seems to hum with a silent presence. While this borders on the metaphysical, modern science offers intriguing points of connection that prevent us from dismissing the idea outright. Geological surveys have shown that a number of major megalithic sites are situated directly upon or near geological fault lines. These fractures in the Earth's crust can create micro-variations in magnetic fields and release subtle gases. More concretely, locations on stable bedrock, like the granite foundation of the Giza Plateau, were not just practical for bearing immense weight, they also provided exceptional acoustic properties. The stone itself could resonate, turning a temple into a giant sound chamber. Researchers like acoustic engineer Stephen J. Waller have proposed that the placement of stones at sites like Stonehenge might have been influenced by auditory illusions, creating interference patterns that would have made sound seem to emanate from the stones themselves during ceremonies. This suggests the builders' connection to their environment was so intimate, it granted them an intuitive, almost empathic understanding of these forces. They were not just shaping the land, they were listening to it, feeling for its pulse and its harmonies. Their greatest tool in this light may not have been a chisel or a lever, but a refined perception, a deep observational science of the living earth that interpreted whispers of magnetism, resonance, and groundwater flow as a clear language. They harnessed these forces not with complex machinery, but with alignment, turning their structures into amplifiers or stabilizers for energies they sensed all around them. In our modern world, insulated by concrete and digital noise, we have largely lost this faculty of perception. Yet, standing in the center of one of these ancient alignments, many still report a palpable sense of place, a quiet awe that hints at the possibility that the builders were working with a fuller spectrum of reality, one where the line between the physical and the energetic was beautifully and intentionally blurred. That blurred line between the physical and the energetic did not vanish with the ancient world. Centuries later, in the misty forests of medieval Europe, another brotherhood of builders achieved a different kind of miracle, one that soared toward the heavens on a skeleton of stone. The Gothic cathedrals like Chartres or Notre Dame represent a pinnacle of medieval engineering, yet they too are wrapped in layers of mystery. Their builders, the master masons of the great guilds, worked with iron chisels, wooden cranes, and compasses, tools we can readily identify. But how they calculated the delicate balance of forces in a ribbed vault, or designed windows that filtered light to create specific emotional and spiritual effects, remains partially obscure. They achieved stunning precision, aligning thousands of tons of limestone to create spaces that feel both impossibly vast and intimately divine, using mathematical principles that were often guarded as fiercely as any state secret. The key to their success was not a single lost gadget, but a system, a living tradition of knowledge passed hand to hand. They relied on the secret geometry of the Masons, a set of proportional rules and geometric constructions based on sacred numbers and shapes like the Vesica Piscis. This was not just theory, it was practical magic. A master mason could walk onto a fresh quarry block with a length of cord and a sharp metal point, and using a series of simple geometric steps, lay out the complex, curved template for an arch or a window tracery with flawless accuracy. These templates, cut from wood or sheet metal, then allowed teams of less skilled workers to replicate the master's design perfectly, stone after stone. The construction itself depended on massive temporary wooden frameworks called centering. These were intricate skeletons of timber that held the stone arches in place until the keystone was set and the structure could support itself. Designing and building this temporary wooden architecture required an understanding of structural loads and wood joinery that was every bit as advanced as the stonework it supported. And just like the wooden machines of antiquity, almost all of this centering was dismantled and reused, leaving no permanent trace of the crucial temporary scaffold that made the permanent wonder possible. This medieval comparison is profoundly illuminating for our earlier mysteries. It shows us that even in an era with better historical records, the most crucial techniques of the master builder were often trade secrets, protected within guilds and transmitted through apprenticeship and ritual. The unidentified tools of the pyramid builders or the masons of Puma Punku may have been precisely this: intellectual frameworks and refined empirical practices. They were not necessarily advanced technologies in our modern sense, but highly optimized systems of knowledge, a deep library of tricks of the trade, material recipes, and geometric shortcuts developed over generations. This was a cumulative, guild-based wisdom where each master added his own discoveries to an unbroken chain. Studying the cathedral builders provides a vital framework, a model for how a less documented ancient culture might have operated. It suggests that the greatest tool was never a single object, but the living mind of the craft, a mind trained to see the world through geometry, to feel the stresses in stone, and to hold a vision so clearly that it could guide a community's effort for 100 years. The mystery, then, shifts from what they held in their hands to what they held in their minds. The living mind of the craft is one thing, but the proof is in the stone. To truly test the theories we have explored, from ropes and ramps to forgotten acoustics, there is only one way forward: to try it ourselves. This is the realm of experimental archaeology, where modern researchers and dedicated enthusiasts step out of the library and into the field, attempting to replicate the ancient feats using only the tools and methods we believe were available. These are not just thought experiments, they are physical trials, and they often deliver humbling, enlightening lessons. A famous example is the Nova Pyramid experiment, where a team of Egyptologists and engineers attempted to build a small pyramid using only ancient techniques. They quarried stone with dolerite hammers, transported blocks on wooden sledges, and built a straight earthen ramp. While they succeeded in constructing a 20-foot-tall structure, the process revealed hidden complexities at every turn. The exact type of soil under the sledge was critical: too dry, and it created catastrophic friction; too wet, and it became a muddy trap. Moving a 2-ton block required not just muscle, but a symphony of coordinated chants and lever pulls, a rhythm that had to be learned through exhausting failure. The experiment proved it could be done on a small scale, but it also highlighted the exponential difficulty of scaling up to a 480-foot monument. Each added ton multiplies the problems. Similarly, on Easter Island, teams have attempted to move replica Moai statues using various hypothesized methods. One compelling experiment showed that a small team could walk a statue upright by rocking it from side to side with ropes, a method that aligns with local oral tradition. Yet, controlling the multi-ton statue's descent down a slope without it shattering on the rock-strewn ground presented a terrifying new challenge, one the original builders somehow solved countless times. These experiments rarely provide a single, definitive answer. Instead, they do something more valuable. They narrow the field. They help separate plausible methods from the physically impossible. They reveal the hidden variables, the kind of practical knowledge that is never written down, like knowing which tree's sap makes the best lubricant for a rope, or how the sound of a stone's ring changes when a hidden crack is forming. What becomes undeniably clear is that persistent, iterative effort was itself a primary tool. It was the willingness to try, to fail, to adjust, and to try again, not for a season, but for generations. This experimental process teaches us that the ancient builders' greatest resource may have been a cultural capacity for long-term, adaptive problem-solving, a form of societal intelligence we are only beginning to measure through the dust of their workshops and the silent, waiting stones. That generational patience is perhaps the most powerful, yet invisible, tool in the ancient workshop. We often search for complex machinery or lost sciences, but we overlook the profound resource of time itself, a dimension these cultures wielded with a mastery we have forgotten. These were not projects measured in fiscal quarters or election cycles. They were endeavors that unfolded across lifetimes, even centuries, allowing for a slow, cumulative refinement that is economically and culturally unthinkable in our modern world of rapid results. This patient iteration transforms what seems impossible with simple tools into something achievable, not through a secret but through sustained, communal will. Imagine a single granite block destined to be part of a sacred wall. A team of artisans, perhaps following in their father's footsteps, would work that surface not for days or months but for years. Their tools were rudimentary: sand of a specific grit mixed with water, and a flat stone or a piece of leather. Day after day, season after season, they would grind that surface in a slow, meditative process. The result is not a rough texture, but a finish so flat and smooth it feels like glass and reflects light like a mirror. This is not magic. It is the relentless application of a basic principle, amplified by a scale of time we no longer dedicate to such tasks. The same principle applied to celestial alignments. A monument's orientation to a solstice sunrise was not calculated in a single night. It was the product of decades, even generations, of meticulous observation. Priests or astronomer builders would mark the sun's rising point on the horizon year after year, noting its subtle shifts with markers of stone or wood. Over a human lifetime, these incremental observations would create a map of the sky's movement, a dataset written in memory and tradition. The final, perfect alignment of a temple doorway was the culmination of this long conversation with the cosmos, a correction made here, an adjustment made there, across the reigns of many kings. This reframes the entire mystery in a humbling light. Perhaps the tools were, in fact, simple. The dolerite hammers, the copper chisels, the sand, and the ropes, they were sufficient. But their application existed within a different framework, a cultural container built on generational continuity and a unified, long-term vision. A society willing to invest the labor of thousands not for immediate reward, but for a legacy that would honor their ancestors and inspire their descendants 100 years hence. This patient iteration was their true technology. It turned gradual abrasion into impossible smoothness. It transformed repeated trial and error into flawless celestial alignment. It allowed for mistakes to be made, learned from, and corrected by the next generation without the project ever being considered a failure. We, with all our advanced tools, have lost this particular instrument. Our brilliance lies in speed and innovation, but theirs resided in depth and duration. The stone bears witness not to a sudden flash of genius, but to the quiet, persistent rhythm of countless hands across the ages, each contributing a little more to a perfection that no single person would live to see completed. That generational patience found its ultimate expression not in a quarry, but in the night sky. The most precise alignments we see carved in stone may have been finalized long before the first foundation was laid, in the minds of astronomers who spent lifetimes watching the stars. This leads us to a powerful and elegant theory that many of these sites were not just symbolically aligned to the heavens, but functioned as monumental astronomical observatories. In this view, the architecture itself was the primary tool, a giant permanent instrument for tracking the complex cycles of the cosmos. The stone circles, the narrow window slits, the carefully placed pillars that cast telling shadows, these were not decorative features. They were fixed components of a celestial machine, calibrated over centuries of patient observation. The Great Pyramid, for instance, with its mysterious, narrow shafts pointing toward specific stars like Orion's Belt and Sirius, may have been designed as a permanent sighting device, locking the pharaoh's journey to the afterlife to the immutable patterns of the night. At Chichen Itza during the equinoxes, the setting sun transforms the stepped pyramid of El Castillo into a serpent of light slithering down the northern staircase, a precise solar event engineered into the very angles of the construction. This reframes our entire search for tools. The builder's most important instruments were not the chisels that shaped the rock, but the knowledge systems that allowed them to design these permanent stone instruments in the first place. Their toolkit was intellectual, a collection of methods for calculating solar and lunar cycles, predicting star risings, and plotting the wanderings of planets against the fixed backdrop of the constellations. This shifts the mystery from the workshop to the observatory, from physical force to abstract mathematics. To achieve this, they needed frameworks for recording and transmitting data across generations. This might have taken the form of early trigonometry, geometric principles that allowed them to translate angular measurements in the sky into linear distances on the ground. Or it could have been a rigorous system of long-term data recording, perhaps etched into clay tablets that tracked the moon's phases for hundreds of years, or encoded within the rhythmic verses of oral epic poems and chants, where astronomical knowledge was preserved in story, passed from elder to youth like a living library. The precision we marvel at was, therefore, baked into the design phase. It was the product of meticulous, long-term astronomy, where the movement of celestial bodies was known with such intimate detail that it could be frozen in architecture. The construction itself was merely the final, physical execution of a complex and beautiful celestial map. The stones were not just aligned, they were programmed, set to perform a specific function at a specific moment in the eternal cycle of the year for millennia to come. This transforms these silent ruins from passive monuments into active participants in a dialogue with the universe, a dialogue their builders planned with a foresight that still takes our breath away. The silent partner in this grand celestial dialogue may have been a vast, invisible machine made of wood. While the stone endures, the most sophisticated components of ancient engineering have vanished without a trace, returning quietly to the earth from which they grew. We fixate on the metal chisels and stone hammers that survive, but these were likely just the final, delicate touches in a process powered by something far more elaborate. The true workhorses were likely monumental wooden machines, complex riggings of levers, ropes, and frames that provided the sheer mechanical advantage needed to dance with mountains. The Romans, centuries later, left us clear blueprints for such technology. The architect Vitruvius described in detail the use of massive treadwheel hoists, powered by men walking inside a giant wheel like a hamster to lift heavy loads. He wrote of compound pulley systems, capstans for winding rope, and towering wooden cranes. This was not magic, it was applied physics, a brilliant amplification of human strength through clever design. It is not a leap to suggest that the pyramid builders or the masons of Sacsayhuaman possessed earlier, perhaps simpler, versions of these very machines. Imagine a system of robust wooden frames anchored firmly into the desert sand or bedrock, from which hung a network of ropes woven from plant fibers. By using a series of pulleys, a team of 50 people could exert the pulling force of 200. With a carefully designed lever and fulcrum, a small crew could pivot a 50-ton stone with a rhythmic, controlled motion. This is the principle of mechanical advantage, and it requires no unknown metals or energy sources, only a profound understanding of geometry and force. The absence of these wooden skeletons from the oldest archaeological sites is not proof they never existed. It is a testament to their organic nature. Wood rots, rope decays. The very materials that made them feasible also guaranteed their disappearance. What we are left with is a negative space in the historical record, a ghostly outline where the machinery once stood. We can attempt to fill that space through reconstruction. By studying later analogues from Rome or medieval cathedral yards, engineers can back-calculate what kind of wooden apparatus would be necessary to lift an obelisk or position a lintel stone. These experiments consistently show that with the right configuration of timber and fiber, the seemingly impossible becomes arduously, sweatily possible. It shifts the mystery from what impossible tool did they have to a different, equally profound question. How did they organize the knowledge to build such large, temporary machines? Designing a crane capable of lifting 200 tons is an engineering feat in itself, one that requires precise joinery, an understanding of load distribution, and acres of suitable timber. This suggests that behind every stone marvel stood a parallel industry of forestry, carpentry, and rope-making, a supporting cast of technologies that have left only the faintest whispers in the soil. Their greatest tool, therefore, may have been a holistic systems mindset, an ability to see not just the finished temple, but the entire temporary ecosystem of machines and teams required to build it, an ecosystem that lived, served its purpose, and then returned to the forest, leaving only the eternal stone to tell its tale. The earth itself may have provided the most potent tools in the ancient workshop. Beyond wooden machines and patient abrasion, a compelling hypothesis suggests these master builders were also practical chemists, wielding a profound knowledge of local geology and mineralogy. They might have understood that certain stones were not inert obstacles, but materials that could be transformed through a deliberate interaction with the environment. This view shifts the narrative from brute force to a sophisticated, almost alchemical, collaboration with nature. It proposes that the builders used naturally occurring acids or alkaline solutions to selectively dissolve, soften, or alter the very surface of the rock they worked with. For example, oxalic acid, which can be derived from common plants like rhubarb or sorrel, has a known effect on calcium carbonate, the primary component of limestone. A poultice made from such plants applied over time could have subtly softened a stone's surface, making precise carving or finishing less laborious. Similarly, some silicate rocks might have been treated with compounds derived from fermented solutions or mineral salts, knowledge possibly gleaned from centuries of experimentation with pottery glazes, metal ore extraction, or the creation of vivid mineral pigments for art. This was not magic but applied chemistry born from intimate, generational observation. The vitrified, almost glazed surfaces found on some ancient stones, which look as if they were briefly melted, lend credence to this idea. These finishes might be the result of an intentional process where heat was applied alongside a mineral flux, a substance that lowers the melting point of stone. By painting a slurry of specific crushed minerals onto a granite surface and then subjecting it to a controlled fire, a builder could create a hard, glass-like protective layer, sealing the stone against weathering. This technique finds echoes in later traditions of ceramic glazing and metal smelting. It reframes the builder not merely as an architect or an astronomer, but as an ecological engineer. Their toolkit was drawn directly from the landscape, a living library of botanical and mineral properties. They knew which vine sap could act as a lubricant, which clay deposit could make a superior mortar, and which springs water, rich in particular minerals, might interact with a quarry face in a useful way. This chemical hypothesis offers an elegant solution to some of the most puzzling aspects of ancient stonework, particularly those mirror-smooth finishes and complex, interlocking joints that seem to defy hand tooling. It suggests the final, perfect fit between two massive stones might have been achieved not by grinding them together for years, but by treating their mating surfaces with a chemical agent that allowed for a precise, almost plastic, adjustment before the material set permanently. This knowledge, like so much of their craft, would have been fragile, passed down as a guarded recipe rather than a written formula, vulnerable to being lost if the chain of apprenticeship was broken. It presents a vision of ancient technology that was deeply sustainable and locally sourced, a harmony between human ambition and the latent potentials of the natural world, where the very mountain could be persuaded to yield its secrets and reshape itself. These chemical interactions with stone hint at a mastery over the very substance of the material world. But what about mastery over the space within it? The precision of the ancients extended beyond the outer form of their monuments into the very air those stones contained. Some of their most sacred chambers were not merely rooms, they were finely tuned instruments, designed with an acoustic intention that we are only beginning to hear. The king's chamber inside the Great Pyramid is a perfect example. Constructed from massive, resonant granite blocks, its dimensions create a specific acoustic environment. Researchers like acoustic engineer John Stuart Reid have conducted experiments within the chamber, using tone generators and recording equipment. They discovered that the room naturally amplifies and sustains certain low frequencies, particularly those around 110 Hz. At this frequency, sound waves interact with the chamber's dimensions to create a standing wave, a phenomenon where the sound seems to fill the space uniformly, vibrating the very stone. The effect on a person standing within it can be profound, creating a palpable, physical sensation of sound, a hum that is felt as much as heard. This is not a random acoustic accident. The granite itself was chosen not only for its durability but likely for its sonic properties, and the chamber's precise mathematical proportions would have been critical to achieving this specific resonant signature. Half a world away, on the Mediterranean island of Malta, lies an even more astonishing acoustic marvel. The Hypogeum of Halsaflieni, an underground temple complex carved from solid limestone over 5,000 years ago, contains what is known as the Oracle Chamber. This small, oval room possesses an extraordinary property. A deep male voice speaking or chanting into a specific niche in the wall produces a powerful reverberation that seems to vibrate through the entire complex, a sound described as both haunting and awe-inspiring. The frequency this niche amplifies also falls within that same significant low range. The sound does not merely echo, it is transformed, gaining a peculiar, penetrating quality that feels ancient and otherworldly. For the builders to have carved this effect intentionally from living rock, they would have needed a way to test the resonance as they worked. This implies the use of simple yet effective sonic tools during construction. They might have employed tuned stones that rang at a specific pitch when struck, acting as a reference. They could have used monochords, a single string stretched over a resonating box, which can be adjusted to find harmonic intervals. Even the human voice itself, trained to hold a steady tone, could have been the primary instrument. A master builder might have chanted while apprentices carved, listening for the moment the stone began to sing back, signaling that the desired shape had been achieved. This pursuit of specific sound transforms our understanding of their precision. It was not solely about aligning with the silent stars above, but about harmonizing with the invisible vibrations within. The architecture becomes a frozen melody, a permanent chord struck in stone. This represents a breathtaking fusion of disciplines. It blends the tangible science of geometry and material properties with the intangible arts of music and spiritual experience. The tool here transcends any physical object. It becomes the understanding of harmonic ratios, the sacred mathematics that link the dimensions of a room to the wavelengths of sound. To design such a space, the architect needed to think like a musician, comprehending how frequency, reflection, and resonance interact within a confined volume. The spiritual implications are profound. In many ancient traditions, sound was considered a fundamental creative force, the vibration that gave form to the universe. A chamber that resonated at a sacred frequency could be seen as a tool for meditation, healing, or ritual transformation. A place where the participant's own body and mind might be subtly tuned by the environment. The precision they sought, therefore, was multidimensional. It was visual in its alignments, astronomical in its orientation, and deeply, intentionally auditory in its atmosphere. They were engineering experiences, not just edifices, crafting spaces where every sense would be guided toward a specific state of awe, contemplation, or connection. The silent stones we see today were once alive with a resonance we are just learning to measure, a hidden layer of their design that speaks to a sophistication that engaged the entire human being. This resonance within the stones required a matching harmony among the people. The most overlooked tool in the ancient workshop was not made of wood or stone, but of human connection. The sheer scale of labor required to build these wonders presents its own profound puzzle, one solved not with physical hardware but with a sophisticated social technology. This was the invisible architecture of organization, the ability to coordinate, motivate, and sustain thousands of workers across decades. Before a single stone could be moved, a civilization had to solve the most basic human equations: food, shelter, and purpose on a staggering scale. This meant creating entire support economies just to fuel the dream. Vast agricultural surpluses had to be planned, harvested, and transported to remote construction sites. Bakeries and breweries, like those found near the Giza Plateau capable of feeding thousands daily, were not afterthoughts, they were the fundamental infrastructure of the project. Temporary cities of mud-brick barracks and administrative buildings sprang up, complete with hospitals, workshops, and storage facilities, forming a complex, moving human ecosystem around the growing monument. This logistical web required a division of labor of breathtaking complexity. It was not just an army of laborers, there were specialist quarrymen who understood the grain of the rock. Engineers who calculated ramp angles, carpenters who maintained the wooden machines, cooks, potters, scribes, and medics, a foreman for every team, and overseers who reported to a master architect, creating a clear chain of command that could translate a grand vision into actionable daily tasks. But feeding and housing a multitude is one thing, moving their spirit is another. The true social technology lay in forging a shared ideological purpose. For many of these cultures, the monument was not a tyrant's vanity project, but a sacred act of cosmic maintenance. Workers might have believed they were serving a god-king, ensuring the sun would rise, or guaranteeing the fertility of the land and the prosperity of the entire community. This shared belief transformed back-breaking labor into a form of devotion or civic duty, a powerful psychological engine that fueled generational effort. You can hear the echo of this coordination in the physical act itself. Imagine the scene of moving a 60-ton stone. A mob pulling randomly on ropes would achieve nothing but chaos and strain. The task required a rhythmic, unified exertion. This is where social technology met physical action. Leaders likely used drums, specific chants, or horn blasts to synchronize the pull of hundreds of workers. 1, 2, pull, 1, 2, pull. The rhythm turned a disparate crowd into a single, living machine, a precision instrument of human force. This synchronization minimized effort and maximized control, allowing the massive block to glide forward on its lubricated track in a steady, manageable surge. This human organization was the ultimate intangible tool, a masterpiece of early administrative and psychological engineering. It was the operating system that allowed the simpler physical tools, the ropes, the levers, the abrasives, to be applied on a truly monumental scale. It reminds us that the greatest wonders were not built by slaves under the lash, but by societies, by communities who had learned to orchestrate their collective will with the same precision they applied to aligning stones with the stars. The monument, in the end, is a fossilized imprint of that social harmony, a testament to what people can achieve when they move together, in mind, body, and spirit, toward a single, distant horizon. That shared rhythm of human effort echoes in our myths as much as it does in the stones. When the physical evidence presents a riddle this profound, our collective imagination has often crafted a dramatic answer, a single, elegant source for all this scattered genius. The legend of Atlantis, or the sunken continent of Lemuria, rises from the depths of this need. These are not historical places we can excavate, but powerful cultural metaphors. They act as a placeholder, a grand narrative we insert into the gaps of our understanding. When we stare at a 50-ton block fitted with machine-like precision and cannot fully explain the how, the story of a lost, advanced civilization provides a comforting resolution. It consolidates all these global mysteries into one cataclysmic event, a great forgetting. This myth speaks to a deep-seated anxiety within our own view of history, the haunting idea that progress is not a straight, inevitable line upward. It proposes that sophisticated knowledge can be gained, perfected over ages, and then suddenly, violently erased, leaving only enigmatic fragments for survivors to puzzle over. The persistence of these stories, especially when we confront the megaliths, reveals more about us than about the past. They fulfill a desire for a simpler story, one with a clear teacher and student, a golden age and a fall. It is often easier to attribute these wonders to a mysterious, superhuman ancestor than to fully grapple with the capabilities of our own human lineage, working with patience and profound intelligence within their own time. This mythological impulse challenges our modern arrogance, our assumption that complexity equals modernity. The stones themselves offer no inscriptions claiming an Atlantean architect. They simply are, and in their silent presence they force a humbling question. Which is more extraordinary, that a single, advanced source taught the world and then vanished without a trace, or that humanity, in many different times and places, repeatedly climbed to such breathtaking heights of understanding using the resources at hand, only to have the specific methods fade as cultures changed and priorities shifted? The lost civilization myth, in the end, is a testament to the awe these structures still inspire. It is the story we reach for when the evidence outstrips our explanations, a narrative acknowledgement that the past may hold chapters of human achievement whose titles we have not yet learned to read. These legends of lost worlds are a powerful story, but modern science now offers a different kind of map. We are no longer limited to speculation or what the naked eye can see. A quiet revolution is unfolding in archaeology, driven by tools that let us peer through jungle canopies, measure surfaces to a fraction of a millimeter, and read the elemental signature of stone. This is a new era of investigation where our most powerful tools are not for building but for decoding. Take LiDAR, which stands for light detection and ranging. Mounted on aircraft, it fires millions of laser pulses through dense vegetation, mapping the ground beneath with astonishing clarity. In the jungles of Central America and Southeast Asia, this technology has revealed sprawling, previously unknown urban complexes, complete with causeways, plazas, and pyramids. These sites show careful planning and alignments invisible from the ground, proving that our understanding of ancient civilizations is still a sketch being filled in by light. It reveals that the scale of their engineered landscapes was often far grander than we ever imagined. Then there is high-resolution, three-dimensional scanning. Archaeologists can now take a handheld scanner to the face of a megalith and capture its surface in minute detail. This digital record is more than a picture. It is a topographical map of every chip, groove, and polish. By analyzing these scans, researchers can distinguish between different types of tool marks. They can see the subtle directionality left by a sawing motion versus the crushing impact of a hammer. They can measure the depth and consistency of cuts to infer the tool's hardness and the amount of force applied. This microscopic scrutiny turns a stone wall into a forensic record, a silent testimony of the workshop floor. Perhaps most intriguing is the analysis of the stone's very essence. Portable X-ray fluorescence devices allow scientists to point a harmless beam at a stone block and instantly read its chemical fingerprint. Every quarry has a unique blend of trace elements, like geological DNA. By comparing the chemistry of a finished block at a temple to known quarry sites, researchers can trace the epic journeys of individual stones across ancient landscapes. But this technology can also hunt for ghosts of another kind. If an ancient builder applied a chemical paste to soften or polish a surface, that treatment might leave behind a detectable trace element, a foreign mineral that does not belong to the native stone. Finding such a signature would be a smoking gun, direct evidence of a sophisticated material science we have only guessed at. These technologies collectively create an objective, digital library of ancient precision. For the first time, we can compare the tool marks on a block in Peru with those on a sarcophagus in Egypt using the same precise metrics. We can search for patterns, for the unique signature of a specific technique that might have been used in both places. This is how we move from mystery towards method. We are slowly learning to read the stones in a language of data, listening for the faint echoes of the workshop in the silence of the ruin. The answers may not be a single lost tool, but a catalog of refined processes, each leaving its own subtle mark in the digital light. This digital scrutiny reveals more than tool marks. It reveals a shared human impulse that transcends data. The enduring power of this mystery lies not in the stones alone, but in what they reflect back to us about ourselves. These silent monuments tap into something primal within the human psyche, a deep well of awe and a profound curiosity about our own origins. We stand before a block fitted with impossible precision, and we do not just see an engineering puzzle, we feel a direct challenge to our modern sense of superiority. It whispers that the story of human progress is not a simple, upward-sloping line from primitive to advanced. It suggests there may have been peaks and valleys, different paths to sophistication that we have forgotten how to walk. This idea is deeply humbling and strangely thrilling. It forces us to reconsider the very definition of ingenuity. We celebrate our silicon chips and space telescopes, but can we truly say our society could muster the generational patience, the unified cultural will, to quarry, transport, and align a mountain of granite with the stars using only the tools of the earth? The question is not about which technology is better, but about recognizing that human capability can manifest in profoundly different, yet equally brilliant forms across the ages. This psychological draw explains why the mystery fuels so much more than academic debate. It is the engine behind countless documentaries that fill our screens, the inspiration for adventure video games where players unlock ancient mechanisms, and the bedrock of speculative fiction that imagines lost worlds. We are not just seeking answers, we are seeking connection, a way to bridge the vast gulf of time and feel a kinship with those minds that saw the world so differently, yet built with such clear intention. At its heart, this fascination is a mirror. When we ask how they did it, we are also quietly asking, what are we capable of? What knowledge have we, in our rush toward the future, inadvertently left by the wayside? The stones present a riddle about the past, but our relentless pursuit to solve it tells a vibrant story about the present, about our own hunger for wonder and our need to place ourselves within a grander, more mysterious narrative of human potential. This is why the search continues, not merely to catalog a forgotten technique, but to recover a piece of our own expanded identity. Perhaps the most profound realization is that no single magical tool ever existed. The true genius of the ancient builders did not reside in a lost gadget, but in their ability to weave a dozen different strands of knowledge into a single, unbreakable cord. Their toolkit was not a box of devices, but a living, integrated system, a synergy of mind, material, and method that we must now attempt to reconstruct in its full, multifaceted glory. Imagine a master architect standing at the dawn of a century-long project. In his mind, he does not see a single solution, but a layered process. He draws upon sacred geometry to lay out the site, using knotted ropes to translate cosmic ratios into foundation lines on the earth. To free the stone, he directs teams to use fire and water, applying thermal shock with the precision of a surgeon to crack the granite along clean planes. For transport, he commissions carpenters to build monumental wooden machines, frames, capstans, and sledges, networks of timber and fiber that turn human strength into titanic force. And for the final, breathtaking fit, he relies on the patient, generational hand of artisans, grinding surfaces with abrasive slurries perhaps mixed from rare minerals, slowly achieving a polish that catches the light like still water. This was not a linear sequence, but a concurrent symphony. The astronomical alignments were calculated by priests watching the stars for decades, their data seamlessly given to stonemasons who carved window slits and doorways as permanent sighting instruments. The acoustic properties of a sacred chamber were not an accident, but a design goal, achieved by shaping resonant stone to amplify specific frequencies used in ritual. The logistical miracle of feeding and housing thousands was the invisible foundation that made the physical foundation possible. This holistic model moves us beyond the frustrating search for a singular secret. It allows us to appreciate the ancient workshop as a complete ecosystem of innovation. The wooden machines provided the brute mechanical advantage. The geometry provided the unerring blueprint. The abrasives and possible chemical knowledge provided the final, flawless finish. And the social organization, the shared belief and generational patience provided the enduring will. Each element alone is impressive, but together they become something transcendent. They explain how cultures could achieve precision that seems to belong to different ages. It was the integration that was the breakthrough. A builder who understood both the stress points in a timber crane and the harmonic ratios in a granite chamber was wielding a form of wisdom that we have since fragmented into separate disciplines: engineering, architecture, music, and astronomy. To see their work as anything less than this grand synthesis is to underestimate them. It is to replace wonder with a narrower, more impoverished mystery. By weaving together the geometric, the logistical, the chemical, and the acoustic, we build a model that is not only more plausible but profoundly more respectful. It honors them not as recipients of alien knowledge or wielders of magic, but as consummate masters of their world, who looked at a mountain and saw not an obstacle, but a partner in a dialogue that would echo for millennia. This holistic view compels us to ask a deeper question of ourselves, not just of the stones, in our pursuit of technical answers. Whose understanding are we prioritizing? The investigation into ancient precision carries with it an essential ethical dimension, one that challenges the very lens through which we view the past. For generations, Western archaeology and popular inquiry have often approached these sites as puzzles to be solved by science alone, seeking the one true technical explanation that unlocks the mystery. Yet, for the living descendants of many of these builders, from the Quechua communities of the Andes to the Aboriginal nations of Australia, these places are not abandoned puzzles. They are active parts of a living heritage woven into stories, ceremonies, and a continuous relationship with the land. Their interpretations are not alternative theories. They are foundational truths preserved in oral tradition, song, and ritual practice. This creates a crucial crossroads in our search for understanding. The scientific method excels at analyzing the how, the angles, the weights, the potential tool marks. It seeks a reproducible material explanation, but indigenous knowledge systems often illuminate the why, the spiritual necessity, the ceremonial process, the deep communal meaning behind why a stone was placed just so, or why a temple aligns with a particular star at a specific time. In many of these traditions, the knowledge of celestial alignment or site selection was not discovered through detached observation, but received through sacred connection. A site might be chosen because it is a place where the earth's energy is strong, a concept known in countless cultures. The act of moving a stone might have been as much a ritual of unity and prayer as a feat of engineering, with specific chants and offerings made to honor the spirit of the stone itself. To dismiss this as mere mythology is to miss a profound layer of the story. It is to ignore a form of data, cultural, experiential, and ancestral that has been meticulously curated and passed down for centuries. When an elder shares that their ancestors built with the help of the gods, or that stones were moved by sound, they are not necessarily offering a literal, mechanical description as we would understand it. They are often conveying a holistic truth that the construction was a sacred act where the physical and spiritual worlds collaborated, where technology was indistinguishable from devotion. Our modern compartmentalized thinking, which separates engineering from religion and science from spirit, struggles to process this unified worldview. We hunt for the isolated tool, while their perspective suggests the tool was the entire cultural and cosmological framework. Respecting this is not about abandoning scientific inquiry, but about enriching it. It means listening to these oral histories not as quaint folklore to be validated or debunked by science, but as parallel, valid streams of knowledge that offer context science alone cannot provide. It involves collaboration where archaeologists work alongside community knowledge keepers, recognizing their authority over their own heritage. This ethical approach transforms the mystery from a colonial extraction of secrets from a passive past into a dialogue with a living present. It acknowledges that the most complete picture emerges when we allow the technical data and the traditional narrative to sit side by side, each informing the other. Perhaps the ultimate precision we seek to understand was not just in the alignment of stone to star, but in the alignment of human action with a profound and sacred sense of place and purpose, a tool of the spirit, whose blueprint we are only beginning to read with both our instruments and our humility. The journey to understand our past is far from over, it is accelerating. We stand at a remarkable crossroads where centuries of speculation are finally meeting the tools of the 21st century. The path forward is no longer a solitary trek for the archaeologist with a trowel. It is a converging highway for multiple disciplines. The next chapter in this mystery will be written by teams where a geologist analyzes a stone's microscopic wear patterns alongside a linguist decoding a newly found tablet, while an acoustic engineer measures a chamber's resonance and a community elder shares an oral history passed down for generations. This interdisciplinary fusion is our most powerful new tool. It recognizes that the secret of the stones is not locked in one field of study, but in the spaces between them. A materials scientist can identify a trace element on a polished surface that an archaeologist might overlook, a compound that points to a specific plant-based treatment. An engineer modeling stress forces on a wooden crane replica can show us the practical limits of ancient lifting technology, and the traditional knowledge holder can explain the why, the cultural and spiritual framework that gave such precise efforts their enduring meaning. Only by listening to all these voices together can we hope to hear the full story the stones are trying to tell. Several tantalizing open questions now guide this collaborative hunt. The first seeks evidence in places where time stands still. We have lamented the decay of wood and rope, but what if some of these perishable tools were lost in environments that preserve organic matter? Think of the anaerobic conditions of deep peat bogs or certain waterlogged lake beds, where wood, leather, and plant fibers can survive for millennia. A future discovery in such a setting, perhaps near a known quarry or transport route, could be revolutionary. Finding a section of ancient, super-strong rope, a preserved wooden lever, or even a tool handle with unique wear patterns would move us from theoretical reconstruction into the realm of tangible evidence. It would give us a physical specimen to analyze, to understand the fiber technology and carpentry that have otherwise completely vanished from the record. Another major question revolves around the very substance of the stones themselves. The geopolymer or stone softening hypotheses remain controversial, yet compelling for certain anomalous features. Future research holds the key to resolution. Advanced spectroscopic analysis could search for a chemical signature in the microscopic matrix of pyramid blocks that differs from natural limestone. If scientists can identify a binder or a reagent that does not occur in the local quarry, it would strongly suggest an artificial process. Conversely, if exhaustive testing across hundreds of samples shows a perfect geological match, it would effectively close that particular door. The answer likely lies not in a blanket yes or no for all ancient sites, but in a nuanced understanding of where and when such advanced material science might have been applied. Each site may have its own unique recipe, waiting for our instruments to become sensitive enough to taste it. Then there is the hope locked within undeciphered symbols and partially understood texts. As computational linguistics and artificial intelligence provide new ways to analyze ancient scripts, we may finally crack codes that have resisted translation for centuries. A newly deciphered word on a Mayan stele or an Indus Valley seal could be a technical term for a specific type of saw, a lever, or an abrasive compound. It might not describe the tool in a manual, but its mere presence in an inventory list or a builder's inscription would confirm its existence. Every translation breakthrough is a potential key, waiting to turn in the lock of a silent workshop. This is the thrilling reality. The mystery of the early stone builders is not a closed book gathering dust on a shelf. It is an active, vibrant field of inquiry where the next discovery is always just beneath the sand. A newly identified quarry can rewrite trade routes. A redated monument using improved techniques can shuffle the entire timeline of a civilization. A laser scan of a forgotten temple wall might reveal a set of precise geometric diagrams, a builder's sketch etched permanently into the sanctuary. Each find is another piece of the puzzle, and sometimes a single piece can change the entire picture we thought we saw. The stones have stood in patient silence for thousands of years, holding their secrets close. But now, with our collective minds and new eyes, we are learning how to listen. The conversation between their time and ours has only just begun. The stones have not given up their final secret, but they have offered us a new understanding of ourselves. From the solstice alignments of Stonehenge to the machined surfaces of Puma Punku, the overwhelming evidence points not to alien intervention or lost super-civilizations, but to the profound, multifaceted ingenuity of our own human ancestors. The unidentified tools we have searched for were likely never a single magical device. They were a combination of lost material techniques, sophisticated intellectual frameworks, and a scale of patient, coordinated effort that defies our modern, accelerated pace of life. This was a synergy of mind and material where geometry was the blueprint, wood and fiber were the engine, and generational will was the unbreakable fuel. These monuments stand as eternal testaments to what humanity can achieve when deep knowledge, unified purpose, and the gift of time converge into a single, driving force. They challenge our linear view of progress, showing us that peaks of human capability can arise in different forms, in different ages, through different paths of understanding. Let this exploration be a reminder that history is not a simple, dusty story written in a book. It is a complex, living tapestry, still being woven with threads we are only now learning to see. The greatest mystery may not be how they built these wonders, but what it means for us to finally recognize the depth of our own shared legacy. If this journey into the puzzles of the past has intrigued you, consider subscribing for more deep dives into history's greatest enigmas. And we would love to hear your perspective. Share your own theories in the comments below. What do you believe was the single greatest tool in the ancient builder's workshop? Was it the geometry, the social organization, or something else entirely? The conversation, like the stones themselves, continues.